Hi, I am Tom and I will present our paper, Share with Thy Neighbors, Single-View Reconstruction by Cross-Instance Consistency. The goal of single-view reconstruction is to output the 3D model depicted by a single image. Despite efforts to reduce supervision, the most advanced methods still rely on multiple views and camera poses for ShapeNet, and silhouettes and assumptions like symmetry or known template shapes for real images. By design, such supervision is limiting the applicability because annotations can either be unknown or coarse, template shapes are not always available, and the symmetry hypothesis can be not valid. In this work, our goal is to learn a system from raw images of an object category, without any further assumption. Our key insight to avoid supervision is to leverage the consistency across different instances. Our system, called Unicorn, is able to produce highly competitive results on diverse shapes from ShapeNet as well as on real images. We approach this unsupervised learning problem as an image autoencoding task where factors related to shape, texture, pose, and background are modeled. Specifically, the decoding part corresponds to the differentiable rendering of a mesh over a background image. Such a model is over-parameterized and is prone to degenerate solution. For example, the background model can overfit the input image, or the 3D can be completely wrong despite the rendering from the input view being correct. We designed two data-driven approaches to leverage cross-instance consistency at its best during training. First, we introduce a curriculum learning technique consisting in progressively increasing the size of the conditioning space in a multi-stage fashion. At the beginning of the training, small latent spaces force representations to be shared across a significant subset of instances. Then, this provides a good starting point to gradually specialize to specific instances by increasing the latent space dimension. Intuitively, this is a pragmatic solution to learn from an over-parameterized model. Second, given an input image and its predicted attributes, we introduce a loss operating on custom reconstructions of neighbors that have different viewpoints. Specifically, given a shaped neighbor with a different pose, we build its reconstructed image using the shape attribute of the input instead. Similarly, we repeat the process with the texture attribute. By applying a reconstruction loss on these outputs, this simple technique explicitly enforces attributes to be consistent across different viewpoints and thus prevents degenerate solutions. Let's analyze the effects of each component by comparing results with our full model. If we remove progressive conditioning, the predicted 3D objects clearly correspond to degenerate cases. If we remove the neighbor reconstruction loss, the shapes are okay, but parts that are not seen from the input views are completely wrong. On ShapeNet, we compare our work with the best supervised methods and obtain comparable performances. Here are some reconstruction examples output by our method. We also demonstrate real image results on various categories like cars, birds, motorbikes, and horses. More details are available on our project webpage.